everyone. Today's lesson is going to be about different angles of polygons. We're going to talk about two different angles of polygons today, the first being interior angles. So we've seen interior angles in triangles before, and it's the same thing for any n-sided convex polygon. So in a triangle, you had three sides, you had three interior angles. The same thing is going to happen with any polygon. So you're going to have the same number of interior angles as you do sides. So in this pentagon here, we have 5 sides and we have 1, 2, 3, 4, 5 interior angles. If I wanted to find the sum of all of the interior angles of an n-sided convex polygon, we're going to use this formula. S equals 180 times n minus 2, where n equals the number of sides that our polygon has. Okay, so in our first example, it says find the sum of the interior angles of an octagon. So we need to know first that an octagon has 8 sides. And then we can use this formula, S equals 180 times n minus 2, to calculate the sum of the interior angles of this octagon. So I'm going to take 180. N in this case is going to be 8 because that's the number of sides an octagon has, minus 2. And we just plug this into our calculator to get 1080 degrees. So the sum of the interior angles of any octagon is going to be 1080 degrees. Number 2 is very similar, except it's talking about an 11agon. So you're going to see this a lot in this lesson if we're talking about a polygon where maybe we don't have a name for it, or it's not a common name that everyone knows. We use n-agon, where n is just the number of sides that it has. So here, this figure is going to have 11 sides. And I'm going to take that value of n and just plug it into my formula here. All right, so 11 minus 2 is 9. So any 11-sided figure is going to have 1,620 degrees. Now, if we look at numbers 3 and 4 here, there's a little bit more work that's going into this. So it's asking us to solve for x. In order to solve for x, there's kind of 2 different steps we need to do. All right, first we need to figure out the sum of all of these interior angles. So this figure is a pentagon. It has 5 sides. So 180 times 5 minus 2. And I know the sum of the interior angles of this polygon, or this pentagon, is 540 degrees. Okay? Now I can take each one of these angles, so 138 plus 19x plus 23x plus 107 plus 17x, and set that equal to 540. I'm going to combine like terms. All right, so I'm going to combine all my x's to get 59x plus 245. All right, I'm going to subtract 245 from both sides. And 59x equals 295. Divide both sides by 59. And x equals 5. Okay. Same idea for number 4. First, I'm going to count the number of sides. So I have 1, 2, 3, 4, 5, 6, 7 sides. I'm going to plug that into my formula. And this heptagon has 900 degrees. That's the sum of the interior angles. So now I can take each one of these angle measures and add them up, set them equal to 900. So 2x plus 112 plus 95. And I'm just going to keep going with each one of those angles equals 900. Combine my like terms, so I'm going to have 4x plus all the other terms will add up to 620. All right, I'm going to subtract 620 from both sides. And 4x equals 280. So x equals 70. All right. Now, numbers 5 and 6 are going to ask us to kind of work backwards. So it says the sum of the interior angles of a polygon is 2,520 degrees. How many sides does the polygon have? So I'm going to use that same formula where the sum equals 180 times n minus 2, but instead of being given the number of sides, I am given the sum. So I'm going to replace s with 2,520 degrees equals 180 times n minus 2. Now, a lot of times when we see something like this on the right side, our instinct is telling us to distribute that 180. We don't want to do that here. All right, we can just divide both sides by 180. And this 180 is, these two 180s are going to cancel out. So I'm left with n minus 2 on the right side, and on the left side, I get 14. If I wanted to solve for n, all I have to do is add 2 to both sides, and n equals 16. So this polygon has 16 sides. All right, number 6 is the same idea. I'm using that same formula. And here it says the sum of the interior angles of a polygon is 5,940 degrees. We want to again find how many sides the polygon has. So same thing, replace that s with 5,940. All right, and again, divide both sides by 180 degrees. All right, don't distribute that 180. You'll get the same answer, but it's just a little bit more work. When I divide 5,940 by 180, I'm going to get 33. And then finally, just add 2 to both sides. All right, so a polygon with 35 sides is going to have 5,940 degrees. Now, if we have a regular polygon, so remember a regular polygon means that all of the sides and angle measures are the same. So we can say all sides and angles are congruent, okay? So if I wanted to find the measure of each angle x, so in this hexagon here, all right, each of these angles are going to be congruent, all right, and we can say that's x degrees. It would be equal to, all right, so that angle is going to be equal to 180 times n minus 2, so that's the sum of the interior angles of a polygon, and then divided by n, okay? Because the numerator is going to give us the sum of the interior angles, and then we're dividing by the number of angles that there are, so that's going to give us each of those interior angles. All right, this only works again for regular n-sided polygons, so be careful that you're only using that formula if you know that it's regular polygon. So number 7 says find the measure of each interior angle for a regular hexagon. So a hexagon, we need to know, has 6 sides. All right, so it's a regular hexagon. I can use this formula, 180 times 6 minus 2 divided by 6. Clean this up in your calculator. All right, and we are going to get x equals 120 degrees. Okay. Now number 8 says each interior angle in a regular polygon is 156 degrees. How many sides does the regular polygon have? So it's giving me each interior angle. I want to solve for n here. All right, so I have 156 equals 180 times n minus 2 divided by n. Anytime I have a variable in the denominator, we're going to want to multiply both sides by that variable. So I have 156n equals 180 times n minus 2. Now, in this case, I have variables on both sides here. I can't just divide both sides by 180, so here I do have to distribute. So I have 180n minus 360. And I'm going to subtract 180 from both sides. So when I subtract 180 from both sides, I'm going to get negative 24n equals negative 360. Okay, and then I can divide both sides by negative 24. And negative 360 divided by negative 24 is going to be 15. Okay. All right. Now, the next type of angle we're going to talk about are exterior angles. All right. Again, we've talked about these with triangles, and it's the same idea. So if I took a polygon and I extended one of the sides in one direction, it forms these exterior angles. So these angles here are all of my exterior angles. Right? The sum of the exterior angles, and this is important, we're only talking about one at each vertex, so we're only extending one of those or the sides in one direction. The sum of those exterior angles is going to be equal to 360 degrees. It doesn't matter how many sides your polygon has, it is always going to equal 360 degrees. So let's try to use this Polygon Exterior Angle Sum Theorem. Here, if I look at this polygon here, all right, it's giving me my 6 exterior angles. All right, there's one exterior angle at each vertex. So I know that the sum of these, when I add these all up, it's going to be equal to 360 degrees. So let's try that. I have 5x plus 78 plus 5x plus 57 plus 25 plus 80 equals 360. All right, combine like terms. So we have 10x plus 240 equals 360. So 10x equals 120, and divide both sides by 10. We get x equals 12. Okay, number 10 looks the same. We've got exterior angles, but here, all right, it really only states 2 of those exterior angles, but if we have a right angle here, we know this exterior angle is going to be 90 degrees, and same with this guy over here, right? So we can now set these 4 angles equal to 360 degrees. So 90 plus 45 plus 5x plus 15 equals 360. Again, combine your like terms, and we're going to get 5x plus 240 equals 360. Subtract 240 from both sides, and then divide both sides by 5, and x equals 24. All right. Our last 2 problems are talking about regular polygons again. So if you have a regular polygon, the interior angles are all going to have the same measure, but the exterior angles are also all going to have the same measure. So we want to find the measure of each exterior angle for a regular 14-agon. So the total would be 360 degrees divided by the 14 exterior angles. And when I plug that into my calculator, I'm going to get 159.7 degrees. The directions tell me to round to the nearest angle, so we're going to round that up to 160 degrees. okay? And finally, number 12 says each exterior angle of a regular polygon is 18 degrees. How many sides does the regular polygon have? So 360 degrees, that's our total, divided by n, some number of sides is going to equal 18 degrees. So I can solve, again, multiply both sides by n, all right, because that's in our denominator. So 360 equals 18n, divide both sides by 18, and n equals 20. And that's our final answer.